Okay, now members, welcome. This is going to be our first topic, and this topic is number systems. These are numbers like integers, natural numbers, even numbers, and so on. Now we are going to see them in details. Okay, so we are starting with now natural numbers. These are numbers that are used for counting items. You know, if you have two bags, you can count that there are 2, 3, 4. So that any number used in counting is called a natural or counting numbers. These include 1, 2, 3, 4, 5. Then all numbers, these are natural numbers together with a 0. So to get all numbers, you add a 0 in the set of natural numbers. So you see, if you add a 0 now, we shall be adding all numbers. Then integers, these are all numbers together with negative numbers. So if you have all numbers, remember they are from 0 and so on. So if you add here negative numbers, they are what we are having is what these are what is called integers. Then square numbers and numbers both after multiplying an integer with itself, e.g. 1, 4, 9, 16, and so on. How do you get them? You multiply an integer with itself. 1 times 1 you get 1. 2 times 2 you get 4. Negative 3 times negative 3 by itself you get 9. Negative and negative you get positive. And then, or you can say you square them. When you square a 5, you get 25. Those are the square numbers. Then cube numbers and numbers got after multiplying a natural number by itself 3 times. E.g., when I get this natural number multiplied 3 times, 1 times 1 times 1. Those are 3 times to give me a 1. So the number I get is a cube number, as you see 1. When I get the second natural number, which is 2, I multiply it 3 times. 2 times 2 times 2, I'll be having 8 there. Then and so on with the 3 and 4 up to when you feel like you want to end. Then even numbers are numbers that are divisible by 2 without any remainder. E.g., so any number divided with a 2 and not get any remainder, we call it an even number. Like you see 2, 4, 6, 8, etc. Then we count only numbers. These are numbers that are not even. Any number that is not even is an odd number, full stop. Prime numbers, this is a number with only 1, 2 factors, itself and 1. So any number with 2 factors, 1 and itself, we say that number is prime. What is a factor? A number that divides another number without any remainder is called a factor. So it's that this number is having 2 factors. First of all, 1 divides 2 without a remainder. Then also 2 divides itself to get the remainder 0. So this number has only 2 factors. So any number with 2 factors is prime. Then composite numbers. These are numbers with more than 2 factors, e.g. 4, 6, 8, 9, 10. But here we say 1 is not a prime number because it has only 1 factor. 1 has only 1 factor. So it can't be a prime number because prime numbers for them they have at least, at most 2 factors. But 1 is having only 1, so it's not a prime number. And it's neither a composite number because composite numbers have more than 2 factors, e.g. 4. You see 4 has 1, 2, 4 as its factors, 6 has 1, 2, 3, and 6, so they are more than 2. So those are composite numbers. Then consecutive numbers, these are numbers that follow each other in a given pattern or counting order. So there is a pattern that you follow to get consecutive numbers. Then regular numbers, these are consecutive sums of natural numbers, e.g. So sums of natural numbers, these are our natural numbers. The first natural number is 1. When you sum the consecutive this and this, when you sum 1 and 2, you get a 3. Now when you sum 1, 2, 3, you'll be having a 6. That's how you get triangular numbers. But there's a simple formula for getting triangular numbers, the nth triangular number. So if you want to get the first triangular number, this is the formula. So the first is when n is 1, the first. You put in this formula, where it is n, you put 1 over 2, 1 plus 1, which will be 1 over 2, 1 plus 1, which will be 1 over 2 times 2, which is 1. When you want the second triangular number, you put here 2. 2 plus 1, which will be 3. 2 over 2 is 1. 1 times 3 is 3. If you want the second, the third, you just substitute in the formula. Rectangular numbers. These are numbers except 2. e.g. 4, 6, these are even numbers except 2. 6, 4, 8, 10, etc. Then so what a factor is. And now let us see factors of 12. Factors of 12, this is that all these numbers are divided in 12 without leaving any remainder. So those numbers that divide the number without leaving any remainder are called factors. What about multiples? In simple terms, multiples of a number and numbers that number is dividing without leaving a remainder. For example, a multiple n has that is divided by a number k, leaving no remainder, is a multiple. e.g. n is a multiple of k. Why? Because k divides n without a remainder. Now, this k becomes a factor of n. n is a multiple of k and k is a factor of n. So multiples, how do you get multiples of 2? To get multiples of 2, you just get these 2, you multiply it by any natural number you want. So 2 times 1, you get 2, 2 times 2, you get 4. Now these ones are the multiples of 2, as you see there. So let us see how we apply the ideas of these numbers. Let us see this question here. The sum of 2 consecutive natural numbers is 11. So when you add those numbers, we don't know them, you get 11. Find the numbers. Now, we said consecutive. That consecutive means these are numbers that follow each other in a given pattern. Now, you count natural numbers. You see, you need to know which pattern are they following. So see that 1, 2, 3, 4. All from 1 to 2 you add 1. From 2 to 3 you add 1. From 3 to 4 you add 1. So they are like sequences by them. So from 4 to 5 you add 1. Meaning, I don't know these numbers, but I know their pattern. So if I have the first as x, then the next I'm going to add 1. So x plus 1. Why? Because the pattern of natural numbers, you add 1 from one term to the other. They're telling me that the sum of these ones is 11. So when I sum them, summing means you add. So x plus, now x plus 1. When I add this and this, I get 11. Now you see x plus x, you get 2x plus 1 equaling to 11. How do I remove this? We subtract this side and this side. When I subtract 1 this side, I get 2x equaling 2. Subtract 1 this side, you have that. And start from there. Our 2x is equaling to 10. Subtract. Then divide through by 2. By 2, by 2, our x becomes 5. So that is the first. So meaning I have x, I need now this one, which is x plus 1. But my x is 5 plus 1, which will be 6. So the numbers are 5, 6. Those are our numbers. So when we add them, we get 11. Then this one, the sum of 2 consecutive odd numbers is 64. Find the numbers. Now, how do I get these numbers? You know that you need to know the pattern of all the numbers. You see, all the numbers are here. What is their pattern? From 1 to 3, what do you add or subtract? But here we add because they are increasing. From 1 to 2, from 1 to 3, I added 2. From 3 to 5, so that we are adding the 2. From 5 to 7, we are adding 2. Meaning, the pattern is correct, so you added 2 from one number to the next number. So, if my first is y, the second is going to be y plus 2. They are telling me they are 2. So when I sum these ones, they're telling me that if you sum this one, we get 64. So now it means when I add 1 plus y plus 2, I'm adding this term plus this, I should get 64. When I add y plus y, we get 2y plus 2 equaling 64. Subtract 2 this side and subtract 2 this side, we have 2y equaling 64 minus 2. So from here, our 2y is equaling to 62. Divide through by 2, by 2, by 2. Our y becomes 31. So if the first is 31, so we have the first, can we get the other? It was y plus 2, which is going to be 31, the y plus 2, which is 33. So these only numbers are 31, 33. Things that they are odd, and so when you add them, you get 64. As simple as that. Then let us see this. The multiple, the sum of 3 consecutive multiples of 5 is 90. Find these multiples. Now, you know that multiples of a number, they are here. So the multiples of 5, the first is 5, the second is 10. 5 times 1 you get 5, 5 times 2 you get this, 5 times 3 you get 15, 5 times 4 you get 20. So that's how we get the multiples. Now, what is their pattern? You see, from this to this you add a 5. From this to this you add a 5. From this to this you add a 5. That's how we get the pattern. Now, it means that if the first is m, the next I'm going to add m, I add a 5. Now, there are 3. If this is the second, it means to get the next, I'm going to get the second, I add a 5. So I add now n plus 5, that is the second, now plus 5. So now these are the multiples we are talking about. To simplify them, this will be m, n plus 5, n plus 10. The pattern is from this you add a 5 to get this. Now from this you add a 5 to get this. Now they are telling me that their sum is 9. So when I add them, when I add this, then I also add the sum is 90. So m plus m, we get 3m. Allow me right here. We get now 3m plus 5 plus 10. I get 15 equaling to 9. Subtract 15 both sides. You get your 3m equaling to 9 minus 15. And then subtract 9 from 15. There we get 75. So now, sum my 3m will be equal to 75. Divide by 3, divide by 3. Our m is, when you divide that, you get 25. So what are they? So if m is 25, it means that now to get others from here, from m we add 5. So they are going to be now 20, add 5 on m. When you add 5 on this, I mean 25, this is 25. When you add 5 on m, you get 30. And then when you add 10 on m, you get 35. And those are going to be our multiples. I think that all of them are multiples of 5. So that's how we get them, members. I wish you well.